Good morning, this is Mr. Morales, and today I'll be going over the notes for day 46, solving quadratics by factoring. Now this should be a review for most students. It was done heavily with the calculator in Algebra 1, so it might actually be the first time you see it, or you might actually be relearning it again for the first time. So there's a ton of examples here to do, but it's a lot of the same thing over and over and over again, as a lot of these processes are in Algebra 1, as we've seen. So let's go ahead and begin with some basic steps and examples. So here it tells us that we could find the roots, the zeros, the solutions to all the quadratic equations through factoring, if you don't have a calculator available, and assuming also you have a good grasp of your times tables, because that's going to be very imperative for this assignment. Follow the steps below, and here's one way to figure out your solutions. And you're going to see this quite a bit on many upper level tests, not only in the college placement, but in actual college itself, because you have to demonstrate how to manipulate these equations to get the answer more than just arriving at an answer, because these steps will be used later on in upper level mathematics. So without any further ado, here we go. Step 1, set the quadratic equation equal to 0. So what you want is an equation in standard form, which is x squared with x and then a number at the end, which is what we have here. They want to make it equal to 0. So what the author of these notes does, because these aren't my notes originals, I wish, but the author of these notes, what they do, they decide to go ahead and take your equation, make sure that after it's in standard form, that you go ahead and rewrite it and make it equal to 0. All right, easy enough. There's step 1. Step 2 says factor the left side. Now, the factoring only works if your equation does already equal 0. Now, what you need to remember is two steps. First of all, since this is a quadratic equation, we're going to have two solutions. In order to get an x squared that we have here in the beginning, we're going to need to multiply an x times another x. Now we need to figure out what has to be attached to this x in order to get the 3x minus 10. And a good rule of thumb is that what you want to do is you want to go ahead and you want to find two numbers that when you multiply them, give you this number at the end, well, really this number with the sign. And then when you add those two same numbers, you get this number right here as well. So let's begin with the ways to get 10. I know that I can get 10 doing 1 times 10 or 2 times 5. And I also know in order to get to a 3, like I have in the middle here, the 2 and the 5 are going to be my best bet. So I'll make a little note over here. I have 5 and I have 2. The problem is I don't know which one of these is going to be positive and which one's going to be negative. So in order to end up with a positive 3, I'm going to need to have more positives. So I'll have a positive 5, and then I'll have a negative 2. So I'll go ahead and write that in here as positive 5 and negative 2. The reason for that is if I go ahead and do FOIL, I would get x times x, which is my x squared. That's what I want. X times negative 2 and positive 5 times x would combine to give me a positive 3x, because you would have 5 x's, take away 2 x's. You get 3 x's. In order to get the negative 10, positive 5 times negative 2 will give you negative 10. So these are my factors here, x plus 5, x minus 2. But these are not the solutions. Solutions are just a simple number on the x-axis where my graph intercepts, if it does at all. So here's where the factoring equations equal to 0, step 3 comes in. So you take each little factor. I'm going to make a little t-chart, as you know I'm a fan of. I'm going to write each factor. My first factor answer was x plus 5. The second one was x minus 2. I'm going to take my first expression here and set it equal to 0. I'm going to do the same thing for my second one also. So now these expressions are equations that are equal to 0. Now I need to solve for x, because I want to know what is x? What is my x-intercept? What's my solution? What's my root? So I'll subtract 5 from the left side and from the right side, and I end up with x equals negative 5. So there's one of my answers. Same thing on the right-hand side, I'm going to add 2 in this case to both sides of my equation to isolate x. And that ends up with x equals a positive 2. So my solutions, my x-intercepts, in brackets would then be negative 5, comma, positive 2. All right, that is the gist of what you'll be doing over and over and over again today. And actually, to be fair with you, for high school students, in Algebra 2, factoring quadratics is one of these rites of passage. Just one of the things that everyone had to do. And maybe if you have an open mind, you guys will realize that it's not that bad and it's actually pretty easy. and can actually be, maybe interesting perhaps. So let's go ahead and just continue this process over and over again. So equation number 1. Our instructions, first of all, directions, say solve the following quadratic equations by factoring. So all these examples are actually easy to factor. The only catch is you really need to have a good fluency of your times tables. If not, it can be kind of difficult. But, let's just go ahead and just jump right into these next examples. So let me change my color up because I'm getting bored of it. That purple. Sorry, purple fans. All right, so here I have an equation in standard form, x squared plus 4x plus 3 equals 0. What I need to do is figure out what two numbers can I multiply to give me a positive 3. Positive 3 is a pretty small number. There's only two numbers that actually give me that, and that would be 3 times a 1. But I need to figure out what kind of numbers, what kind of signs to attach to them in order that when I add my two numbers, I'll get a positive 4. Well, in this case, if I have a positive 3 and a positive 1, those will add up to a positive 4. If I multiply positive 3 times positive 1, I'll get a positive 3 like I have here at the end. So these are my factors. So I'll start with my parentheses. It begins with x, because that's how I get my x squared right there, which I use a triangle for, ironically. And I'll attach the positive 3 and the plus 1 inside. Great. Those are my factors. Easy enough. But I need to find the actual x-intercepts, my roots. So I'll make my t-chart again. And this side represents the x plus 3 expression. This side represents the x plus 1. I'll turn these expressions now into equations by setting them equal to 0. And now all I do is simply solve these one-step equations to isolate x for both of them. On the left side, I get x equals negative 3. On the right side, after I subtract 1 from both sides of the equal sign, I get x equals negative 1. So my x-intercepts, my roots, are at negative 3, negative 1. Remember to try to go from least to greatest. That's pretty much standard mathematical notation. Moving on, I'll go ahead and go over, I guess let's go straight down. I'll leave you guys to do the evens on your own. So moving on to number 3. Same exact process. Again, it's in standard form. That's a good thing. It's equal to 0. Check. I need two numbers. That'll give me a 2. A negative 2, really, and then two numbers when I add them to give me a positive 1. So how can I get a negative 2? Let's see. To get a negative 2, or to get a 2, I know I have 2 times 1. All right, easy enough. How do I end up with a positive 1x? Well, I would need a positive 2 and a negative 1 taken away from each other, or taken away from the 2, in order to end up with a positive 1. So my factors are positive 2 and negative 1, because positive 2 times the negative 1 will give me a negative 2. That's what I want. And positive 2 plus a negative 1 will give me a positive 1, which is what I want there. So I have my parentheses, x and x with a positive 2 and a minus 1. I'll go back to my t-chart, and I'll go ahead and begin solving both of these expressions for 0. So actually become equations. And after I do my work here pretty quick, I get x equals negative 2 on the left. And if I add 1 to both sides over here, I get x equals positive 1. So my solutions, my roots, are negative 2 and 1. Picturing my trend going straight down. Let me go ahead and change my color because I've grown tired of that green now. You do this all day. Sometimes the only benefits you get are changing the color to make it a little more interesting. Not that I wasn't kind of dissed towards you guys, it's just kind of, liven it up a bit sometimes when you're doing the same thing for every class. So, enough of that digression. Moving on to number 5. So here we have another standard form equation, perfect, set equal to 0, check. Now I need some factors. I need to get a 21. To get a 21, I already know two numbers that'll give me a 21 when I multiply them. And those two numbers are 7 and 3. In order to get a positive 21, I can do positive 7 times positive 3. But if I add 7 and 3, I won't get a negative 10. So I have to go back to remembering my rules for signs now. I do know to get a positive 21, I can multiply two negative numbers. Because a negative 7 times a negative 3 will be a positive 21, which is what I want right here. A negative 7 plus a negative 3, or plus 3 more negatives, if you think of it that way, gives me a negative 10. So my factors are x minus 7. As I write a plus sign, so let's go ahead and fix that up. I say one thing, do the other. Say one thing, do the other. And then I have x minus 3 is my other factor. So I'll go ahead and just make those instantly into my t-chart. And I'll solve each expression as an equation equal to 0. Simple one step. And when you do some of these other examples, you will get decimal and fraction answers. And don't let that, throw you off. That's totally allowable amount. There's no rule that says quadratics can have fraction decimal answers. So just roll with it. The process stays true if you stay true to what you're doing. So my answers here are plus 7 and positive 3. So my roots then, in order from least to greatest, would be 3, 7. Try to keep that trend going from least to greatest when you write them in the brackets. And the last on this front side of our notes, number 7. Standard form, check. Equal to 0, check. Now to find my factors, I need to get a 25. 25 is a perfect square, and I get that with a 5 and a 5. 5 times positive 5 gives me a positive 25. That's what I want. And positive 5 plus a positive 5 gives me positive 10. So my factors are x plus 5 as well as x plus 5 repeated. So here's an interesting example of something that you haven't seen yet in the previous examples. So in this case, we'll keep going with the process. No matter what you see happening, it will work out. Make it equal to 0. There we go. Solve it on both sides. When you do that, I'm sorry, it's a little sloppy and rushed. I'm playing with this, hopefully. I get x equals negative 5 over here, and of course the same thing over here. So really, even though I did 2 factor solutions, I really only have one true solution. And my root then would be just that negative 5. I have to write it one time because it only really, this is one of those parabolas that only has one solution and just barely touches the x-axis before going back up again. And if you don't believe me, you can always graph it yourself and check. So let me go ahead and move on to the back of our notes, as I literally flip mine over. Okay, so now, here we have some alternate examples, and I like these ones. So number 9, this one is not in standard form, but it does have a form that we've seen before. It's not standard form, but we can factor something out of it. On number 9, what we really have over here on the left side is oops, let me lock this down, is x times x, which is an x squared. Then I have minus 8 times x equals 0. I want to break it down so you can see something. Do you remember factoring? We did this before the break. What's common to both the left side of my equation, my left term and my right term on my equation? And that would be a single x. So I can take an x out from the left side and from the right side and bring that on down. Parentheses, I'm left with an x minus an 8 equals 0. Okay, now you're wondering, how would I solve this? Well, I really do have 2 terms here. Here's my t-chart. So here what I'm going to do is just say x equals 0 on the left, and then I make this other term, x minus 8, equal to 0, which I already still have. Go ahead and solve that one, because that one actually has a step I can do to solve, and I get x equals positive 8. On the left side, it just told me specifically what my answer is. So my roots, my x-intercepts, and brackets from least to greatest are at 0 and positive 8. All right, so that was nice and interesting. I actually did not expect that right away, but that's cool. Moving on. Number 10 works the same way, so I'll leave that for you guys. Let me go on to number 11 here on the left side. 6x squared minus 12x equals 0. This is another factorable one again. What's the biggest number that goes into 6 and into 12? Well, that would be a positive 6. 6 will go into itself in the beginning here one time, and it will go into negative 12 over here, negative 2 times. Because 6 times 1 is 6. 6 times negative 2 is negative 12. Now I have those x's to deal with. I have x squared over here, which is 2 x's basically, and then I have a single x over there. So I can go ahead and take out an x also from each side. So I take out an x there, and I take out that x there. So now I'm left with a single x that fell down, and then I have this minus 2 right here. all equals 0. So these are basically my factors again. I have 6x equals 0 on the left, and I have 1x minus 2 equals 0 on the right. The right-hand side one is exactly what we did in the previous, so that one's pretty fast to do. And then I suspect some of you might get caught up on this. Well, go ahead, divide both sides by 6, and you still get x equals 0 over here. So our solutions, our x-intercepts, our roots, are at 0 and 2. All right. Now let's go ahead. And number 12 does behave actually the same way too. Number 13. Here we have, it's not factorable per se, but it's a perfect square. I have an x squared and a 64. 64 is the result of when you have an 8 times an 8. So in order to get a negative 64, they both can't be positive. They both can't be negative because I'm making it positive again. So one of these has to be negative. It's your choice. I'll just pick the one on the left. So our solutions then would be x minus 8 and x plus 8. Let's go ahead and factor both of these. Set them equal to 0. Solve each one just like we did previously. We get x equals positive 8 on the left. And I think you can go to the right-hand side might be going. We end up with x equals negative 8 on the right-hand side. So our solutions from least to greatest would be x equals negative 8 and positive 8. Going down to number 15. So number 15, this one is going to be a perfect square also, because 4 is a perfect square number, which is 2 times 2. So if I have my parentheses, I know to get a 4, I would have a 2 and a 2. To get an x squared, I would have an x and an x. So now I kind of do what I did before. 81 is a perfect square of 9 times 9. But to get a negative 81, one of these has to be negative, one has to be positive. So I'll make the second one negative this time. So I have a positive 9 and a negative 9. I'll go ahead and make these both equal to 0. So I have now 2 step equations. Sorry about the bell there. Minus 9 gives me 2x equals negative 9. Over here, 2x minus 9 equals 0. I didn't finish the left side yet, don't worry. I know what I'm doing. Plus 9 gives me 2x equals positive 9. Divided by 2. X equals whatever half of negative 9 is. And then over here, divide by 2. And x equals half of whatever positive 9 is. So my roots, my solutions, are at negative 9 halves, which is negative 4 1/2, and positive 4 1/2, or positive 9 halves. Those are my solutions there. And let's wrap up the bottom part. So now we have some equations that are not in standard form. Well, we've already kind of experienced that. But here's what they mean. When you have the 3 parts to make your equation in standard form, but they're not in the right order. So remember, standard form is ax squared, I'll write it over here on the left, is something with x squares, and then stuff with x's in the middle, and then some number attached, either positive or negative at the end, all equaling to 0. So in this case, number 17, my equation does not equal 0, it equals 21. So an easy way to get rid of that 21 to make it equal 0 would be to subtract 21 from both sides. When I do that, I have x squares, I have my positive 4x's, then I have this minus 21 at the end, because you can't subtract 21 from stuff with x's. And then I have my 0. So now I have my equation that can be easily factored. I need to have an x, and an x gives me x squared. I need 2 numbers that give me 21. The 2 factors I always think of are 7 and 3. In order to get a negative 21, one of these has to be negative. In order to add them together, I need to get a positive 4. To get a positive 4, I'm going to need to have positive 7 and then take away 3. Because positive 7 minus 3 will give me a positive 4, and positive 7 times a negative 3 will give me negative 21. So there's my factors there. Using the process from above, I make sure it's going to be opposite x equals negative 7, and then x would equal positive 3 when we do the work. So x solution, my intercepts are at negative 7 and at 3. The same process applies to number 18. So make sure you put the 4x after the x squared and put in standard form. Number 19, here we have more than 3 terms. So I'll go ahead and do the same exact thing that I did above. I need my equation to equal 0. So I'll subtract 7x from both sides. When I do that, my x squared falls down. Negative 5x's minus 7 more x's gives me negative 12x's. My minus 64 falls down. And then my equation equals 0 and is in standard form. I begin my factoring process with my x and my x. To get a 64, I know it's going to be an 8 and an 8, but 8 times 8 or 8 plus 8 will not give me negative 12, so I need a different version of 64. So I'll kind of rack my brain here, and I need something in the teens. Well, if I double 8, I get 16. And if I cut the other 8 in half, I get 4. And those will still give me a 64. So I have 16 and 4, but I need to somehow, I need to get a negative. So one of these will have to be a negative. To figure out which one's going to be negative, I need to look at my middle term over here. I need to get a negative 12. That means I need more negatives than I do positives. Because negative 16, and if you only add 4, you'll end up with negative 12. And negative 16 times a positive 4 will give you a negative 64, which you want there. So minus 16 plus 4. You may have to figure it out with some other ways before you get the right answer. That's perfectly okay. So here I get x equals positive 16, and x will equal negative 4 over here. So my x-intercepts will be at negative 4, and then at positive 16 down the line. And finally, on the left-hand side, number 21. Now, my equation does not equal 0, so what I'm going to do is I'm going to go ahead and subtract the minus 11x from the left side and from the right side, since it's the only piece that's by itself. When I do that, I get 0 over here. X squared, 1x squared, minus 11x squared will give me negative 10 x squared. So I begin that x so big, plus 8x's with no numbers at the end. Well, this is one that I'm going to have to factor. So I can ignore that plus 0, and I need to figure out how to get what is common to both 10 and 8. The biggest number that goes into 10 and 8 is going to be a 2, because 2 times, excuse me, I haven't pulled this out the way. Let me go ahead and erase this and start over again. Hopefully I'm right. Okay, so let me re-explain this. So I need to just figure out what is common to 10 and 8. So I know that 2 is, so I can say 2 times negative 5 times x is the same thing as negative 10x squared. I can say 2 times 4, which will give me the 8, times x gives me 8x. What's common to both? Well, I can take out a 2 from here and here, and I can take out an x from here and here. So that's my first factor. What's left over? Well, then I have a negative 5 and an x plus a 4. That's my second factor. So 2x equals 0 just means x is going to equal 0 because 2 times 0 is 0. I have to solve this one. Negative 5x plus 4 equals 0. It's a two-step equation. Minus 4 from both sides. I get negative 5x equals negative 4. So I have negative 5 on both sides. I get x equals, negative divided by negative is a positive. So my solutions are at 0 and 4/5, which is 0.8, I believe is decimal. All right, so there's a rundown of the process. The right-hand side of your notes will be yours to show, to demonstrate, and practice on your own. Feel free to contact me if you need to figure out if your solutions are correct. Best of luck on this assignment. Let me reiterate, this isn't an assignment. Best of luck on these notes. The assignment will be the next following day's lesson.